In this video, we're going to take a look at the present value function. And in this particular example, we're going to use the present value function to determine how much a lottery winnings are worth. Okay, what the present value of a lottery winning is. So, as you know, if somebody wins a lottery for $100 million, they don't get $100 million lump sum. They get, let's say it's spread out over 20 years. They would get $5 million a year for 20 years. Okay. If they choose to take the lump sum, that would be something less than 100 million. And the way that they calculate that amount is they figure out if I were to put a certain amount of money in the bank and earn a fixed interest rate on it for 20 years, and I were to withdraw that 5 million, leave the rest of it in to earn interest, and then a year later I'd withdraw 5 million and so on, then when it got down to the very last payment at the end of the 20 years, there would be exactly $5 million left. I'd withdraw it and my balance would be zero. So you'd come out even. In this particular example, we're not doing 100 million, we're going to do 20 million. And so let's start identifying the numbers. So what I want to know is if I'm trying to find the present value, and the annual interest rate, it looks like 6%, so I'm going to put 6 up there. And it is a 20-year lottery, and we're just getting one payment at the beginning of every year, so we're going to put a 1 in there. Usually it's a 12, but this time we're going to put in a 1. And our regular payment is going to be $1 million every year for 20 years. So I'm going to put in 1 million. And my ending balance will be 0. And the payment is going to be at the beginning of every one of these periods. So now let's go over here and let's zoom in on this a little bit. Okay, so let's go over here. We'll put in the present value function. So let's go to our formulas tab and go to our financial functions and scroll down to the letter P. And let's do present value. And our rate is, now in this case, the number up here and the number down here are the same, but it's still best to use this number and this number down here, just in case the number of periods per year would change or the number of years would change. So we'll still use these numbers. Okay, so my rate per period is going to be the 6%. Click or tab down in the NPER and then click on C9. Payment is always a negative number, remember, so put a minus sign in front of it. And the payment is going to be, well, I left a 0 out of that. That's supposed to be $1 million. I'll put that in a minute. And the future value is going to be 0. And the type is going to be this number down here. And then let's click on OK. And so what I need here is, let me see, I just need to put an extra 0 in. So let's go and put another 0 in, and it should recalculate for us. Okay, so what this is saying is that if I took the $12,158,116.49 and put it in the bank and earned 6% on it every year, and at the beginning of the first year I took $1 million out, so I'd have $11,158,000 left, and I earn interest on that for the year, then obviously I'll have more than $11,158,000 at the end of the year. I'll pull $1 million out of that at the beginning of year 2, pull $1 million out at the beginning of year 3, and so on until I get all the way to the beginning of year 20. And when I get to the beginning of year 20, I will have exactly $1 million left in my account, and I withdraw that, and I'm down to 0. Okay? So this is what the lump sum would be if 6% was the assumed interest rate. So if you know that you can earn that much on it, and they offer you more than this amount of money, then you should take the lump sum. You will be able to withdraw $1 million every year for 20 years, and you'll still have some money left over at the end. If the lump sum is smaller than that, and you can only get 6% interest on it, then if you withdraw $1 million every year, somewhere along the way, before you hit 20 years, you're going to run out of money. So that's how you would decide whether to take the lump sum or not, although in actual practice, it seems almost everybody ends up taking the lump sum. So let's check this answer. Okay, so how would you check the answer? Well, this is our present value right now. That's the amount of money that you have. And this is what your payment's going to be, is $1 million. You're going to earn 6% on the money. You're going to have 20 years to pay it off, and you're going to make the payments at the beginning of the period. If you use all those numbers, then we know that our ending balance, our future value, should be 0. Okay, so I'm just going to go off to the side here, and we're going to invoke the future value function. And the rate is going to be the 6%. Go down to NPER. That's going to be 20. Payment. Now, in this case, the payment is going to be a positive number. And in this case, the reason is because the money is coming from the bank to you. You're withdrawing the money, and that is in a positive direction. Money going to the bank is considered a negative direction. So this is the one case where you do not need to put a minus sign in front of it. And so we're just going to click on C6. Now, the present value is money that's already been deposited in the bank. So that's like the sum of a bunch of payments. And so I'm going to put a minus sign in front of that, and then I'm going to click on this. And then I'm going to go down here, and I'm going to click on type, which is 1. And it tells me my future value is 0. And yeah, that is exactly what I was expecting it to be. So this number and this number over here should be equal. And if they are, we've just checked our problem and made sure that we've done it correctly.